All right, welcome back. Today, we are pulling back the curtain on the hidden architecture that powers, well, pretty much everything in our digital lives. The data center network. Yeah, your social media feeds, your movies, all of it, it starts right here. So let's jump in. And you know what? That is not an exaggeration at all. The first time you walk into one of these places, it's just incredible. It's this buzzing, humming, physical heart of the internet. And really, to understand tech today, you got to understand how these places are put together. So, what exactly is a data center? Well, think of it this way. It's a massive, specialized building packed with rows and rows of computers. Kind of like a giant library, but instead of books, it stores pretty much every website, every app, and all the data you access online. For the longest time, data center networks were built using a very specific, kind of rigid hierarchical model. Let's dig into this classic three-tier design because it really set the stage for everything that came after it. It was a really simple top-down structure. So picture this. At the very bottom, you've got the access layer. These are the switches sitting at the top of each server rack. They plug up into a middle layer, the distribution layer, which then all funnel up into this massive, super powerful core layer. And that core, that was the main highway in and out of the entire data center. And this whole setup, it really tells you what it was built for. It was designed for what we call north-south traffic. Just imagine you, a user, way up north on the internet, asking for a web page from a server way down south inside that data center. The entire network was fine-tuned for that one specific journey. But then, technology did what it always does. It changed. And this perfectly logical design suddenly had a huge, crippling problem. The digital highway it was built for, it wasn't the busiest road anymore. Not even close. And this brings us to the big turning point in our story. What was it? What single technological shift just completely shattered this old model and sent network engineers scrambling back to the drawing board? One word: virtualization. Suddenly, applications weren't just living on one single server anymore. Nope, they were being broken up into all these smaller pieces, running across many different servers in many different racks. And all those little pieces, they needed to talk to each other, constantly. And just like that, a whole new kind of traffic was born, and it became the dominant one: east-west traffic. This is server-to-server chatter happening completely inside the data center. Instead of flowing up and down, traffic was now zipping sideways from one rack to another. And this wasn't some small shift. I mean, just look at this chart. East-west traffic totally exploded. It quickly became something like 80% of all the communication inside the data center. We had built a network for the 20%, and it was getting absolutely crushed by the other 80%. So you can see the problem, right? For one server to talk to another in a different rack, its traffic had to make this long, ridiculous journey, all the way up to the core and then all the way back down again. It was inefficient, it was unpredictable, and it created these massive bottlenecks that slowed everything to a crawl. So something had to change. The industry needed a new blueprint, one that was built for this new east-west reality. And the solution was, well, it was elegant, it was powerful, and it was a complete reinvention of network design. Enter the spine leaf model. You know, I love this quote because it just perfectly captures the spirit of this new design. We're about to throw out those neat, clean, hierarchical tiers and embrace something a lot more interconnected, a lot more meshy. So how's it work? Well, we still have switches at the top of the rack, but now we call them leaf switches. Then we have this new backbone layer of powerful spine switches. But here is the absolute game changer. Every single leaf switch connects directly to every single spine switch. It creates this incredibly dense, interconnected fabric. Now, this whole design follows a few really simple but really powerful rules. Spine switches only ever connect to leaf switches. Leaf switches only ever connect to spine switches. You never connect a spine to another spine, and you never connect a leaf to another leaf. That strict rule set is what makes the whole thing work so beautifully. Okay, so why is this meshy design so much better? What's the big deal? Let's break down the real-world advantages that made spine leaf the gold standard for pretty much every modern data center. 2, just 2. That's the magic number here. That is the most important number in this entire story. In a spine leaf network, any server can talk to any other server in exactly 2 hops, always. 1 hop from its leaf switch,
up to a spine switch, and one hop from that spine back down to the destination leaf. Every single time.
And when you put them side by side, the difference is just night and day. Path predictability goes from a slow, variable mess to being fixed and lightning fast. Bandwidth, which used to be wasted on blocked backup links, is now 100% utilized. The whole network is built for the east-west traffic that actually dominates. And scaling, it's so much simpler. You just add more spines or leaves. It wins on every single front.
Okay, now for all you network folks out there, here's the secret sauce. The old model used a thing called spanning tree protocol, which actually had to shut down redundant links to prevent network loops. It was wasteful. SpineLeaf uses layer 3 routing, which means every single cable you plug in is active and passing traffic. No more wasted potential. Every wire is pulling its weight. But you know how it is in tech, right? The story never really ends. The SpineLeaf architecture, as revolutionary as it is, has now become the foundation for an even more complex, even more powerful layer of networking on top.
See, the physical network of switches and cables we've been talking about, that's called the underlay. But on top of this, the big guys, your Googles, your Amazons, they build a virtual overlay network. And that is a whole other world of mind-blowing automation and flexibility. But that's probably a story for another day.
So you can see how we got here, right? We went from tiers to spines because virtualization totally changed the game. And that just leaves us with one final question to think about. With this absolute explosion of AI and data, what new traffic patterns are coming? And what new, brilliant architecture will we have to invent to handle them?